What is the biggest design challenge you've experienced when creating an IoT design? Is it the RF by chance? Yeah, I'd say a lot of us would point to the RF aspects of an IoT design as being the most difficult challenges to overcome. But what if all of that was taken care of for us? What if Bluetooth and Zigbee were already completely integrated and all of our certifications and regulations were all done and out of the way? Yeah, I'd call that IoT made easy. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Shishir Malav from Microchip and I explore the benefits of the PIC32CX-BZ2 and WBZ451 multi-protocol wireless MCU family and how it can make IoT design easier than ever before. We investigate the components included in this multi-protocol wireless MCU family, the details of the software architecture included in this solution, and how you can utilize these MCUs for your next design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Microchip. Hi, Shishir. Thank you so much for joining me.
Hey, it's nice to be here.
Excellent. Shishir, we're talking about Microchip's first PIC MCU with BLE, which leverages Microchip's robust Harmony ecosystem. Before we jump into the details, though, what kind of applications are we talking about here?
Sure. And before we jump into the applications, let me give you a very quick sort of rundown on why you would want either Bluetooth or Zigbee or both at the same time. So if you look around yourself, you'll see Bluetooth's present in every single device that you have, TVs or laptops or smartphones. So the applications for Bluetooth in consumer market space especially are limitless. And then on the other side, Zigbee is a popular mesh network protocol, meaning if you want a lot of devices to be talking to each other over a larger distance, essentially, like in a warehouse or in a factory, then you would need Zigbee. So the biggest sort of market that we look at for this family is the IoT space. So we're talking connected sensors, smart devices like smart thermostats or smart garages. And on the industrial automation side, you could have connected lighting in massive warehouses. These are some of the few examples that off the top of my head I can recall for this product.
So, Shishir, how many variants are there in the PIC32CX-BZ2 family?
Yeah, we've got two different types of packages. So one is the SoC. Then we have also done, using the same SoC, we've built an RF ready module. And that module comes in two different variants. One, the WBZ451PE module, has a onboard PCB antenna on it. The other one, WBZ451UE, that has a U.FL connector. So if you're developing something that needs an external antenna, you can then use that one. There's no other differences between the two modules. On the SoC side, we have the SoC in two temperature ranges. One goes up to 85 degrees Celsius, which will be suitable for most use cases. But we do have extended temperatures on the SoC, which can go up to 125 degrees Celsius. Those will be suitable in harsher environments like heavy industries or any environment where temperatures can go really high. So 125 degrees Celsius is AEC Q100 grade 1 rated SoC.
All right. So tell me more about this SoC. What all does it include?
So this wireless MCU SoC is leveraging the vast experience that Microchip has in building microcontrollers, which it has been doing for decades and decades, right? So this one features a 1 megabyte flash, 128 KB RAM, and it's powered by a Cortex M4F running at 64 megahertz. In terms of GPIOs and peripherals, it has 29 GPIOs and a 12-bit ADC with 8 channels for premium analog performance. And it also comes with a quad SPI, so you can add more flash if your application requires that. And in terms of wireless, we have a Bluetooth 5.2 protocol and a Zigbee 3.0 protocol capable of running simultaneously through hardware arbitration. There are plenty of different profiles on both the protocols, Bluetooth and Zigbee, and maybe we'll talk about those in the coming slides. In terms of security, it does pack a punch here. It comes with a 256-bit AES with error code correction and true random number generation. There's a lot that we have added to keep your application secure from remote attacks.
So, what about the WBZ451 module? Why would someone want to go for this module over the SoC?
Absolutely, yeah. So it's the same PIC32CX-BZ2 SoC in a compact form factor within a RF-ready global regulatory certified module. So when we talk about RF, it takes a lot of efforts and RF expertise to design any RF product, right? So what we have done is we have taken away that massive hurdle by creating a module with all of the RF work already done. All you have to do is take this module, put it on your design or on your board, and as far as RF is concerned, that's it. Another thing that comes with RF design is regulations. You have to have regulatory certified for the region you're operating in. And what we have done on that front is that this module comes with a large number of these regulations already certified. For example, this is certified in the US, Canada, Europe, China, Japan, Taiwan, and Korea. This will save customers a lot of time and a lot of money because the regulations can take from anywhere between 4 weeks to a year, and it can cost up to a few $1,000, right, for each of the regulations. So all of this adds up. And what we are trying to do with this module is enable our customers to go to market quicker.
Okay, so Shishir, what would you say are the biggest benefits for the PIC32CZ-BZ2 family?
There are multiple layers of benefits in the PIC32CX-BZ2 family. On the development side, you can prototype really quickly, especially with our GUI-based IDE. You can just drag and drop your code. So you'll just be dragging a block and the code will be generated. You can obviously customize stuff, but to get started to prototype, it doesn't take that much time. And we have a number of debug tools for the wireless protocols as well. And then since this is an MP Lab Harmony based IDE or development platform, you have access to thousands of other products from Microchip, and integrating those is really easy. It's as easy as drag and drop, like I said. So it's an ecosystem that's powering billions of devices today in real world, right? If you're familiar with this MP Lab already, you will need no time to ramp up. Even if you're not, it's designed in a way that even the first time users of this IDE will be able to program or develop their applications in no time. On the other hand, we also have features like mobile app code. So if you're developing a Bluetooth app, more than likely you'd want a mobile app to go with it. So we provide iOS and Android app for you to test, as well as the source code for both of those. So you can either customize that, have that as your starting point to develop your own app. Those would be some of the bigger sort of advantages that will enable a customer to go to the market quicker.
Okay, so Shishir, let's say someone is interested in evaluating this family. How would one go about doing that? Are there any development boards available?
Yes, we do. They're currently available. Our development board comes with pre-programmed demo applications. So depending on your individual use case, if you're just developing Bluetooth app, you can just power this on, choose to run the Bluetooth app. If you want Zigbee, you can do that. And if you want both of those running simultaneously, that's also there. So literally no development work is needed to evaluate the wireless protocols, whichever suits your needs best. And in no time, you'll be connecting with your smartphone through Bluetooth and provisioning Zigbee over BLE. All of that is included in the development board. As soon as you power it on, that's good to go. Another thing that we have on the board is a microbus interface, and there are hundreds of different micro click boards available that will add more sensors, for example. So if you wanted to add anything quickly, you can just pop one on and you're good to go.
So, Shishir, what about documentation? If someone is just getting started with wireless development, can they still develop with the PIC32CX-BZ2 family?
Absolutely. Regardless of your experience in wireless, our teams have created a very comprehensive developer's guide, and it'll walk you through each and every step in a way that you will be able to develop your own application from scratch, even if you have no wireless experience. It's as simple as downloading your MPLab IDE, the right family part pack, and it's all documented, by the way. So even if you miss any of this, you can go back to the application developers guide and it will walk you through everything, as well as show you some of the applications that we have developed for you. So if you just want to try those out without developing anything, you can do that. The most helpful thing for first time developers would be, I would say, the building blocks that we have created. And it is our step by step walkthrough to create a Bluetooth application from scratch.
Fantastic. So, let's talk more about this IoT made easy.
Yeah. So this IoT made easy is our philosophy when it comes to wireless, right? So it can get intimidating with how many different protocols there are, and you need to know the hardware level knowledge, all of that. So what we have tried to do is create as much collateral and demo applications as we can to give the developers a starting point. So you're not reinventing the wheel every time you want to do that. The two big applications we have developed and are available right now, these are all available on GitHub. These are smart thermostats, and this will show you different peripherals that went into building this, as well as how to configure them in MP Lab. You will have all of that detail. In case you just wanted to try it out without actually configuring anything, we have the hex files available as well, and you'll be able to just program your board with the hex file and you'll have the application running in no time. Another full application that we have developed is Smart Garage. So it has a phone interface and a motor control built into this one. So if that's something that you're looking to build, that's a good starting point. But if you're just looking for some individual interfaces or peripherals, we have built a lot of those as well. So we have application examples for PIC32CX-BZ2 working with a touch panel, working with an OLED display, or working with Wi-Fi. So there's a lot of these demo examples that we have provided. On the same front, we have also developed a lot of collateral on the protocol side of things. So how would you connect, say, a Bluetooth sensor to smartphone? We have an application example for that. How would you use multi-link and multi-role? We have an example for that. If you wanted to operate your PIC32CX-BZ2 product in deep sleep and get it out of deep sleep, wake it up, and then advertise and go back to deep sleep, we have an application example for that. Similarly, for Zigbee as well, we have done a ton of different examples, including sensors and lighting. And then we have a couple examples on the multi-protocol side. So Bluetooth and Zigbee are running simultaneously, and you can see how seamless and reliable, and many other examples as well on there.
Okay, so Shashir, can we also talk about the Harmony ecosystem a bit as well? What's all included?
Right. Yeah. Harmony 3 is essentially where you will find all your libraries and drivers and application examples that we talked about as well. So you can just choose one of these application examples and program your board with that. So Harmony 3 also actually has the other microchip products. So if you're trying to build a product with PIC32CX-BZ2, for example, and you want other microchip devices on the same design, you don't have to figure out how the libraries will talk to each other. You just add them, drag and drop, and you will have access to those peripherals and those other microchip products as well.
Okay, so this solution includes both Bluetooth and Zigbee. So, what kind of profiles are we looking at for both of these?
Bluetooth Low Energy has offered a lot of very useful profiles in the recent years. So to begin with, it has the low energy. Another one is coded PHY, which will enable you to get much longer range. And I'm talking hundreds of meters. Gone are the days where Bluetooth was just 10 meters or whatever, right? Now you can get up to a few hundred meters in range on Bluetooth. That's remarkable. If you're looking for a higher throughput, you can use the 2M5 profile. If you want to connect to multiple devices, you can do that. We support 6 devices simultaneously on Bluetooth through Multilink. And if you add multi-role, you can extend that up to 30 devices. So if your use case does not need a large mesh network, you could just get away with using Bluetooth. And because it's such a low power and a stable standard, it's always good to go that way. On the Zigbee front, since Zigbee is heavily focused on light, so we have a bunch of those light profiles, the extended color light, dimmable light, on-off light. These are all Zigbee light profiles. We have the thermostat, we have the proxies, the alarm systems, and all of these are covered in the application developer's guide, a big rundown on what these profiles will be used for, how to configure. But this is the highlight of all the major profiles that we have included in this PIC32CX-BZ2 family.
Okay, so Shishir, can we look closer at the memory footprint as well?
Yeah, so like I said, it has a megabyte of flash, right? So depending on your application, so if you're doing a multi-protocol application, this is what it could look like. It definitely varies with the specific application that you're developing, obviously. But around about, just to give you an idea, if you're doing a Bluetooth stack and a Zigbee stack and want over the air updates, then you're left with around 132 kilobyte of space. A little bit used on the Harmony 3 side, on the development side, but yeah, we estimate the Bluetooth and Zigbee stack to be around about the same. But in case OTA is not something that you're interested in, or if you need more flash, OTA usually reserves half of the entire flash for redundancy purposes, right? That's way more than anything most people will develop. So you have ample space for any application that you have in mind. And on the storage side as well, if you do need to add another flash to this family supports quad SPI. So you could do a quad SPI attached flash and still have OTA with a very big application. Now, if we talk about just Bluetooth, then things change. So you no longer need the space for Zigbee stack, and you will have more space for Bluetooth, and vice versa. So if you don't need Bluetooth anymore, you will have a lot more on the Zigbee application stack available to you.
So, what does the software architecture look like, especially when it comes to multi protocol?
So on the file layer, we have the hardware arbiter that I talked about earlier, which makes multi-protocol just a breeze. So yeah, you've got the radio, then the arbiter. So depending on what's needed, it does Bluetooth, Zigbee, and then on top of that, we have the actual modem for both. On the software layer, it starts with the arbiter manager and then your Bluetooth or Zigbee stack. The protocol APIs is what you will be interacting with in your application code that sits at the very top. And all of the APIs are explained in the application developer's guide. So all of that information is available. And if we talk about just a Bluetooth or just a Zigbee application, then it'll be the same thing minus, the other protocol that you're not using. So at the very base, you have the radio, and then you'll have the modem. You won't have the arbiter because you don't need that with a single protocol. So you'll have the modem and then the software stack for that protocol. You then have the APIs that will expose the profiles to your application code. That's about it on the architecture side. Depending on what you're trying to do, things can get complicated, but we've tried to keep it simple.
Excellent. Well, Shishir, I think that's all I have time for today. Thank you so much for joining me.
Thank you so much. It was a pleasure to be here, and I hope you will give this product a try.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Microchip. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talks section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/